Okay, welcome everyone. Thank you for joining us today for this talk on Apache Druid. Atlanta, we are doing it as part of Big Data ATL Meetup group. We are almost 3,000 member group, and we started as a Hadoop user group and combined a few of them and made this big group. And now more than ever, we are very relevant and we have to continue this journey. We are in a very exciting time right now. And I am one of the co-organizers. We have Craig and Michelle and Will, also part of our organizing committee for this meetup group. And I'm really excited to be here to present this topic today. I just recently got invitation to lead the IT of Women in Big Data. It's just recently became a non-profit organization. We have been as an organization for 5 years, but only recently became non-profit, and we are going to, please welcome all of you to that group as well. Contact me or find out more information from me, and I'm giving my LinkedIn here. And that's about it. So now we have an Imply team. Eric Lucas and Mike McLaughlin are here to give us introduction to Apache Druid. It's a very fascinating time. Long time ago, we had the databases. We found out a great data store. We were working on databases, and then we couldn't hold all the data. We couldn't process everything. So, and then big data technologies came about 10, 12 years ago, Hadoop and everything were the pioneers, but there is no real time there. We have to process, but it gave an opportunity to analyze really large volume of data, which we couldn't do before. And then we became really, now we want to be able to analyze faster. And that's where Apache Druid stands out because of the columnar database distributed data store. And, we have exciting team to talk about that. So I welcome Eric to start on behalf of Imply. And followed by Mike, our chief speaker today. He's going to talk about all the exciting things and also going to give us a demo. Let's get started.
Yep. Thank you, Chelsea. I appreciate it. So I'm Eric Lucas. I'm the sales director here in Atlanta for Imply, sell the communications companies mostly. It was funny you're talking about databases. So I back in the olden days, I actually worked for a startup company back in the mid-'80s called Oracle. So I sort of went through why do I need a database? I have a flat file system, or I'm running vSAM or something else. So yeah, things have changed dramatically. So Mike, let's go to the next slide. So I'm going to give you the real quick commercial, a couple quick things. So the marketplace that we go into is really similar to everybody else's. What's affecting our business right now? It's obviously a unique time. Data is growing rapidly. People want to make decisions in real time, especially now that everybody's working from home. It's really changed. Especially if you're a developer or software engineer, pressure to develop new features and services really quickly. We're finding that our customers, the data engineering teams, are just absolutely overwhelmed, and as a result, benefits get delayed. And with people now working from home and the whole economy changing, this is becoming more apparent every single day that we work with. Mike, next slide. So let me give you a quick overview of Imply. So Imply we are the commercial version of Druid. Our founders of our company are the developers, the original developers of Druid, which is now an open source through the Apache Foundation. We do a few different things that make us a little bit different than the open source version. We have a community group, so help host meetups and arrange meetups like this today. We have a services team that'll do architectural services, integration, installation services, and we also have 24/7 support. And then we've got a number of different features that make Imply's version of Druid a little bit different. I think Mike will touch on it a little bit today, but we've got a BI tool that we call Pivot. It's really for non-technical users to do very technical decision-making in real time. We have a manager that manages our clusters. We have a performance and health management dashboards also. So Mike, I'm going to get off the sales pitch. I'll let you do the technical routine. Any questions that people have, please put in the chat box. I know Mike really can't see the chat box. I can see it. So I will disturb him with questions that you have, and he will like being interrupted a little bit. So Mike, I'll let you go take it away.
Cool. Yeah, thanks everyone. Yeah, thanks Eric. Yeah, if you have questions, definitely feel free to interrupt me. I don't mind at all. I'll see the chat, but Eric's going to help me out and keep an eye on it so I don't miss anything. But if you have some that's relevant, feel free to interrupt me. So what are we doing here? We're going to do a quick introduction to Apache Druid. I'm going to start on a high-level overview. I've got a bunch of real-world use cases that we're going to go through so you can kind of see where it fits. I'm also going to talk through the architecture so you can kind of see a high level how it works and why it gets the speed ups that it does. We're going to focus in on primarily on kind of where to use it and how to use it, and so on. Kind of where does it fit in the data landscape. I'm a field engineer with Imply, so I've been working here at Imply for about 18 months. I don't have a big data background at all, so the way I've kind of built this presentation and this talk is kind of all around my journey through learning Apache Druid. So hopefully it'll help some of you out if you're new. And if you've been with Druid for a little bit and you know about Druid, there's been some exciting developments. I'll talk through some of the changes that have been coming up recently, and talk a little bit about where we're headed on some of the other changes that are coming to the open source world. We talked about Imply, and so I won't mention Imply much more than to say I work for them, and they offer some products and services for Apache Druid. So let's dig in. Let's start right off. And again, if you have questions, feel free to drop them in the chat or interrupt. If we start off at the very beginning, what is Apache Druid? If you go and look at Druid's website, you're going to see this really concise description of Apache Druid. And if you really think about it, it boils down to just the high performance database, and it's really focused on real-time portion of that. So it's a high performance database that's really focused in on real-time analytics. That analytics means aggregations, counting, ranking, statistics, all the normal things you kind of think of related to analytics. But the key to it is that it's a database. And so it fits sort of where you expect it to fit where you would put a normal database. But when you're thinking about ingesting data, excuse me, you're going to be ingesting data typically from streaming data sources. So we're very frequently connecting to Apache Kafka or AWS's Kinesis, Azure Event Hub, all Google Pub Sub, all those typical event streaming platforms. That's typically where people are focused on connecting Druid to. If I look back on the last year and a half that I've spent with Druid, it's probably 50-50 in terms of connectivity from streaming data versus batch data. But there's definitely been a growth in streaming data. So you're starting to see more and more of that real-time access. There's still use cases where you're going to see connectivity to batch, and for sure there's always a use case to drop in older data where you've got a new customer, a new data set coming in for that's going to backfill some data. But typically it's real-time focused, and so I'll probably focus most of this talk on looking at something like Kafka connecting to Druid. On the other side, pulling data out, applications that we're traditionally seeing connecting to Apache Druid are very focused in on the business critical applications, things where performance is really important. If you think about and I'm going to go through kind of the top features of Apache Druid, but if you think about where it fits where performance is critical. So that's on both sides. That's why most people are connecting to something like Kafka, where you can get streaming data in under a second and make it queryable within a second, basically. So if you have a business critical application, think of something like sensor data or network telemetry, where you're actually making a decision based on that data. you need the latency between the point at which it arrives in your Kafka topic or your Azure Event Hub or Kinesis. You need the point in time which it arrives there until it's queryable to be as small as possible. Druid fits that really well, and typically we're seeing customers asking for SLAs of under a second for that latency, typically under 10 seconds for sure. So pretty common to see really low latencies there because you're making decisions off of that. If you think of somebody like someone that's got sensor data, where you're making decisions off of a current temperature or a leak detection or something like that, those decisions need to be made quickly. And so that's where something like Druid fits really well. On the other side, if you think of performance, it's the query performance as well. So querying Druid is really meant to be as fast as possible. But the key thing here is that it can feel like a database to anybody who's familiar with SQL. So you're going to be querying against the Druid engine with a SQL-based query language. If you're familiar with Druid, you've probably seen the older native JSON-based query language that's being sorry, was there a question? Okay, cool. So that's being slowly deprecated over time. It'll always be there, of course, but because you can, if you're familiar with it, you probably like it and enjoy that flexibility of it. But the push is to get closer and closer to 100% SQL compliance, and we're getting closer. If you've been watching Druid for a while, you may know from the past that Druid traditionally didn't support joins, for example. So that was one area where there was a lack of compatibility. But just recently, over the last 3 months, we've got join support. So I'll talk a little bit about that, and we can talk about the limitations that are there right now. There aren't many. We're getting pretty close to full compliance there. So getting much closer to that. So on the other side, again, performance is usually important. Scale of data is usually quite large. There's a kind of a reason why you're coming to something like Druid. We'll talk a little bit about some more of those kind of things that differentiate, but those top two are generally the ones that jump out at most of the time when you hear about why someone is using Apache Druid. Self-service and interactive sort of ad hoc analytics, that's a pretty common theme now. Most of the time users are asking for more and more access to data. And if you're a data analyst or if you're a product manager, you're getting a lot of requests from users to say, give me access to this report or that report, or I need to change one of these existing reports to include more data or different dimensions, or add on a different group by, et cetera. So kind of giving that back to the hands of those users is what most people are asking for, and that's sort of where we see Druid fitting in really well. We'll talk a little bit about why, but that's kind of a very common use case where it's self-service, giving people the access to their data to be able to drag and drop their own dimensions and add in whatever they're looking for on their own. So doing deep analysis, and then both internal and external user. I've got a bunch of real-world use cases I'm going to go through. You'll see a mixture of both internal, external users on all of those use cases, and we'll talk through how folks are using it. Key features, I think I mentioned most of these. The top two are the ones that I generally think of when I think of where does Druid fit, just being really fast. So you have a need to get low latency ingestion. Again, on the ingestion side, you're trying to minimize how long it takes to get and access the data. And then on the other side, querying data. So having your SQL query results come back to you in under a second is pretty typical. Multi-dimensional queries, so doing more than one dimension, and typically filtering on many dimensions. You may only filter on one at the beginning, but kind of like a search engine, you're making changes and you're doing this ad hoc querying. That's pretty common within Druid, and a lot of the kind of use cases I see kind of fit into that model. On the scalable side, Druid is a clustered database. We're going to look at the architecture, so you'll see all the different pieces. But the clustering really helps make the scaling really easy, because Druid can scale each of its individual services on its own. And we'll look at a couple of those pieces in a minute. But you can scale up and out. So you can imagine having a really large scale instance where you have 64 cores, for example. So you can scale it up and have more services running on a single node, or you can scale out. Excuse me, you can scale out where you can have more nodes with excuse me, spread out across the cluster. So the other part of scaling is scaling the data, access to the data. It's not just scaling the ingestion level, so scaling to be able to meet, in some cases, existing Apache Druid users are seeing 10 million events per second coming into the Druid cluster. So scaling to meet that ingestion, but also scaling to meet the historical level. So if you want to add data for the last year or 2 years, being able to scale out the cluster to be able to support that, in addition to scaling the ingestion. Those can be scaled separately, and we'll talk a little bit about that.
Hey, Mike, we have a question. Let me read it to you. For live data ingestion, batch ingestion, do they serve on different purposes? For example, we have live clickstream data sets sending to Kafka and ingesting in the Druid. We just made the live Kafka ingestion recently. Meanwhile, we also have batch ingestion of a whole set of historical clickstream data sitting in S3. I'm a bit confused here how we should use the historical data for batch ingestion and how we should deal with the live data.
Yeah, so I think I'll cover a little bit of that as I walk through. For live data being ingestion and batch ingestion, you're going to see there sometimes are different purposes. Most users that I see are ingesting the data into one data source and then querying it together. And a good example is looking at data right now versus a year ago. A kind of a retail example is a really simple example there. And then, kind of looking back in time versus right now. There are other use cases where we'll see batch data coming in and being used for a single purpose. There's some healthcare customers that I've been working with for this use case where they're looking back just at the historical data and comparing, claims kind of data, if you will, not really looking at live at all. And they'll separate that out. Live is used for one side and batch is used for another. So I think I'll answer the second half of that question in a second, though, because I've got a better use case. And I'll answer the Redshift question in just a second, too.
Okay. Thank you.
So on the scalable and fast and scalable, again, those are the kind of things that my number one and number two when people are asking me about what Druid's good for. Scalable in the sense that we can scale up and out. I was mentioning if you scale out, you can actually do tiering as well. So you can do things like put all of the live data, for example, on a hot tier and make that a really fast query and response time. And then put like the 3 months and older, for example, on a colder tier where it actually is a slower, cheaper instance. But you're okay with that SLA being a little bit slower. Druid handles that really, really well. It's all automatic, and the SQL doesn't change at all. You don't have to change anything about that. The backend handles the figuring out where things are and where to go and how to. So we'll talk a little bit about how it does that in a second. The bottom four features there, I generally think of as kind of table stakes anymore, but I'll quickly talk through how Druid meets them. Resiliency and fault tolerance. Druid's built-in, got this built in, so it's kind of, and we can happily dig into this more as needed, but fault tolerance kind of built in all the way across the service plane. The services themselves are all fault tolerant, and the data is replicated. There's version segments. There's a lot of aspects going on to really make the infrastructure resilient. Getting data in and out, we talked about that. It's really efficient and really easy and fast. Data access used to involve a native query language. Now you're talking SQL. So just making things really easy to get in and out of data. The security, data is encrypted at rest and in transit. User authentication authorization is provided. Kind of, again, what you kind of expect out of a database these days. So where does Druid really fit in this kind of overall view? And this will come back, Julie, to a part of where I was headed with your question. Excuse me. I think of like batch data and this live data coming together in one spot, and that's how I'm going to focus in on this fit answer, I sort of turn it around a little bit and start looking at how are you going to access the data and how quickly you need a response to it. And that tells us whether Druid's going to fit or not in my mind. And so I think of like cold data where you've got, typically you're okay with the response time being minutes or hours or days is even fine. It's okay if I get a report back to me in 2 days. And there's a lot of use cases like this. And there's a lot of places where if you got a response back in an hour, it's okay. There's typically very complex queries for that. You guys have probably all written some of those complex queries. Having the latency from when the data comes in until it's queryable is less important than just having an accurate report. Then on the other extreme, you've got what we term hot data. So this is where you need a very, very quick response to a query. Typically it's under a second, but generally in my mind, I'm thinking of less than 5 seconds here. So you're okay with it taking a few seconds maybe, but you need that ability to kind of cycle through. And this is, again, all coming back to how the end user is accessing that data. So they're asking a question of their data and then getting a response back, and then maybe making a tweak to it, kind of that self-service ad hoc model. That's sort of on the other extreme. Latency is important here, even extremely important, again, for those kind of use cases I talked about. We have sensor data, et cetera. And then in the middle, you have what we term warm data. It maybe it'll certainly require a quicker response than days or hours, typically 30 seconds, maybe less than a minute, might be a little bit better. The types of queries you're running are ad hoc in nature, but they might be more focused on a dashboard where you might be looking at a dashboard, but it's okay if it takes 10 or 20 seconds to come back. Maybe it takes longer to generate a report for longer amounts of time, a time window longer than that. Latency is important, but not critical. You're not making business decisions off of the values that are coming into the system. If you think about where Druid fits on those far right ones. You can certainly use Druid for the cold data, but ultimately, if you think about efficiency and cost for performance and so on, Druid might be overkill for those use cases, but it fits perfectly on the hot use case. And I kind of put the Druid logo there on the warm data tier, positioned more towards the hot side. As your data becomes closer and closer to cold, where maybe you're okay with it taking 2 minutes for the answer to come back to you, that kind of gets closer to the cold. And you can use all your typical tools you're used to. You Hive writing Hive queries against your data in HDFS and so on. All the usual queries that you're familiar with. Druid's not intending to replace any of those. It's really just trying to help make these hot use cases a lot faster. Where we usually see Druid fitting in, again, if I focus in on the use cases and where it really fits, it's really about getting data back quickly, responding to queries fast, and generally speaking, very high concurrency. So kind of like that use case where there's an ad hoc element to the queries and the nature of the way the user is interacting with the data. And the user may be a system. In the case of the first use case there, the risk and fraud analysis, that's very typical systems. It's actually running that in code, so you might actually be a person looking at that. In some cases it is. We're gonna look later at an example from DBS, the bank DBS. They use Druid for risk analysis and actually look at for anti-money laundering use cases. So they actually spoke at the last Druid Summit. They're a heavy user of Apache Druid. So, but it also kind of goes from traditional banking kind of examples over to a little bit closer to that supply chain example where there's a couple of large electronics suppliers that are using Apache Druid within their supply chain and manufacturing, looking for fraud actually within that chain. So kind of on the very easy end, looking for where someone's marking something as defective and it doesn't match what your expected rate of defect products is, all the way over to kind of doing more detailed analysis of supply chain fraud in and of itself. We have a use case on that I'll show you. The next one, the network performance use case, if you've read any blogs about Druid, you've probably seen a couple about network performance. Think of this as the typical network flows, doing data coming in from routers and switches and so on, that data lends itself really well to the Druid use case. As you can imagine, you typically have a need for the latency to be very small to be able to do analytics on that. And you're typically doing things like comparing batch or older data against live data. And so that live data that you're looking at, you're saying, is this look like a familiar pattern? Compare it to maybe last year at this time or a week ago, et cetera. So network performance as well as network analysis, and doing, again, the kind of detection of looking for any bad actors in the network. That's a pretty common use case. User behavior analysis is another really common use case. This is things like click streams and so on. I have a number of use cases here that we'll talk through. There are, again, a lot of blog posts about user behavior analysis using Apache Druid. It fits really well because of that kind of flow of data that I was talking, or flow of process that I was talking about earlier, where user behavior analysis, you're typically looking at, who is using my web page and sort of funnel analysis, that kind of thing. And it lends itself really well to an ad hoc self-service use case, so kind of digging in and making sense of data on your own. Digital ads is the other really popular use case. Digital advertising is where Druid got its start, so it's a natural fit for Apache Druid. I'll talk a little bit about that in a second. Real-time data warehousing, we talked through that with the hot and cold and warm use cases. Metrics and APM, so doing performance analysis is really, really common. So this is things like activity logs from your, or event logs coming from your applications, your internal applications, or even existing applications. This isn't really meant to replace something like an app-D, but really just augmenting it is, and I'll show you an example of this. eBay is a really good example of this. In fact, app-D is uses Apache Druid and has spoken about it as well. We'll talk about that use case in a bit. And then finally, the time series and IoT use cases, that is the one I kind of use in my stories that I was telling earlier. The sensor example is a really common use case. IoT in general is a really common, relatively new, but very common use case. And if you look at like kind of the breakdown, this was a year ago, a little over a year ago, there was a survey sent out to all the Druid users and really asking them, how are you using Druid? Digital advertising, no surprises at the top. Again, that's where Druid got its start. We'll talk about that in just a second. User behavior analysis and web and mobile analytics. I kind of, in my head, I group those together, but broken apart here. You'll find a lot of use cases there, and I think all of the ones that, all of my favorite ones to talk about are in that space. So you'll probably get tired of me talking about those. Application performance, I mentioned that one as an eBay example. That's probably the top 4 that's there. But if we look back in time and we look at how Druid got its start, it got its start at a company called MetaMarkets, and MetaMarkets was providing analytics to buyers and sellers of programmatic advertising. We all are really familiar with this now, especially with all the time we spend on news sites and web in general and so on. MetaMarkets was built around trying to help both sides of that, try to make sense of the data, basically. And if you can imagine that, you've got billions of advertising events per month. So this is back in 2000 or the late 2000s, so 2006, 7, 8, somewhere in that general region. So we're talking billions of events per month. And now I'll show you an example that's very similar to this use case, and it's in the trillions of events per month. And 30 dimensions, and now you're looking at something more like 100+ dimensions. But in any case, even at that time, as Chelsea was saying, like, when the big data movement kind of started, you were able to put some of this data into just a traditional database. And then at some point you realize billions of events per month is just not going to fit into MySQL, for example. And you start looking for other databases and other systems to be able to try out. When you look on the other side, the user of something like this is actually looking to get access at the data very, very quickly. They're doing analysis, and they're doing that granular analysis that I was talking about. They're very self-service. So I'm an advertiser, and I'm trying to figure out if I target this specific ad at female executives who are between ages 35 and 44 and are in the US, UK, and Canada, and they read sports blogs on weekends. If you think about all those kinds of attributes, doing that attribute, that detail of a query is not something that, if you're doing things like pre-aggregations and doing all this kind of work up front, it doesn't respond very quickly typically. And so being able to answer a question like that is what Druid was really built for. It was built to be able to allow you to make changes and look at that. If you think of like somebody who's analyzing their advertisements, if you think of someone like Coca-Cola or someone, some big advertisers trying to make sense of how their ads are being viewed by different age groups, and if they make a change to a specific ad, did it have any impact? And looking then forward and saying like something like this, if I targeted an ad at this specific demographic, how's it going to perform? So making those kinds of ad hoc kind of queries is just not something you can kind of pre-plan for. There's no way to know which dimension someone's going to query on. And so when the team at MetaMarkets got kind of busy trying to figure out what's the right tool to use for this, obviously all the traditional kinds of things were explored, and each of them had pros and cons about them that made them something that they should be considering, and then something that they should maybe take a closer look at, and then in other cases trying to maybe wish that some of those things didn't exist. And so that's how Druid came about, basically taking all the pros from those, in particular time series OLAP and search systems, and bringing them together in one system. You can see the various pieces that came from each one. And of course, with that, Druid fits a very specific use case. And so we'll talk a little bit about how it's made up, but just briefly before we go into the architecture, a little bit about the community. Druid was open source in 2012. So after several years of development within MetaMarkets, then MetaMarkets got sold off to Snap. And from just before that, they got open source. In 2019 to last year, became a top-level Apache project. You can see the stats there. There's a number of contributors from 30-plus contributors from 15 different organizations, and over 30 committers, and over 300 contributors. So it's being used at over, over 1,000 companies. So it's really widely adopted across a large number of different types of users, different types of companies, and different industries. I'll talk about a few of these in just a second, but you can see that it's spread across not just one specific industry. It's kind of spread itself out. And so it's got quite a bit of adoption and started to get some early adoption and then some spread basically after that as people started to see where it was used. All right, I'm going to talk through a few of the core concepts, and then we'll look at an overall architecture. At its core, Druid has a data source, which is similar. If you think about it in your mind, you can really think about this as a relational database table. That's the way I visualize it. And if you're writing a SQL query, that's how you can kind of think about it. It's obviously a little bit different than that, but that's probably the best way to kind of compare and contrast it with other systems. You can see in my example there, I'm streaming events in to the data source. Those events are JSON based. The events themselves can be JSON, CSV, Parquet, any number of ORC and so on, any number of different file formats. They're coming in and they're actually stored in segment files. So these segment files are basically shards of the database. And they're sharded first by time. So there's an element of time which kind of naturally goes with event-based data. And so if it's this live event-based data, almost always it's got a timestamp. If you don't have a timestamp, you can get around this. There's ways around it, but almost always data coming into Apache Druid has a timestamp because it fits really naturally with real-time event data. These segments, these shards that are built up you can kind of picture them as an hour block of time or a day. They're basically sharded into a window of time. You have flexibility to kind of control how those are sharded. And those shards are actually stored in what's termed a deep storage. This is basically a cold storage for segment files. Cold storage is traditionally something like HDFS or AWS S3, et cetera. We're not querying directly from there. Those segments are basically just stored there for backup. Basically, they're kind of a disaster recovery and cold storage location for the data. Along with that, there's a component called a metadata database. Typically, this is Postgres or MySQL. These databases are storing just metadata, so which probably makes sense given the name of it, but very simple things like what data sources are in the system, how many segments, where are those segments. You can have segments stored in multiple deep storage locations technically, so where are they physically, and then what rules about moving segments from tier 1 to tier 2 and so on, all that kind of metadata, all that stuff you expect. When you bring things up a level and start putting the pieces together, once there are basically 3 primary services, and once the segment files are created and in deep storage, they're actually going to end up on what are termed historicals. And so if you look at the Druid docs, you'll see a service called historical. The historicals are actually managing and serving those segment files. So one segment file, again, might be a day in time, might be an hour, and each of those segments is going to be loaded somewhere on one historical, and they might be more than one. They might have replicated data for resiliency. As we talked about earlier, you can actually run Druid all on a single node if you really want. So, so in that case, you'll have one replica of the data. Those historicals kind of mirror the indexer side. That's the ingestion engine. So you can think of those as the middle managers, or you can, if you're looking at the docs, you'll actually not think of them. You'll see them called the middle managers. I think of them more in my head as indexers. So I term them indexer, and actually there's a service that's slowly being replaced. So you'll see it slowly being turned indexer, but that's where all the segment files you can see in my picture there, probably poorly drawn, but those little black boxes are what I think of as the segment files. As events are streaming in from Kafka or wherever they're coming from, those the indexer itself is creating those files. Once you hit the time window, that segment files and submitted off to the deep storage, and then eventually lands on a historical for loading. But if and we mentioned this earlier, you can scale each of these independently. So if you've got like a new customer coming on board, or if you've got data you need to load, a big bulk load of data, you can scale up your indexers separately. And then the historical side, if you want to keep 1 year always active, and then whenever there's an audit, maybe once a year, you're going to bring online the last 3 years. You can bring that online and scale up your historicals to support that. You can also, of course, tiering is built in. I didn't really draw that out there, but you can again separate out your historicals by tiering and have a faster tier, slower tier, and so on, as many tiers as you want. Querying itself works by data as being, again, kind of coming in. So you're getting data into the indexer. You also have data on what I'm terming there, the data nodes, but those are historicals. You've got data in both those places, and it's the query broker's responsibility. That's a different service. That broker is responsible for figuring out where are the segments that you're looking for. So looking at the SQL query, if you're doing a select statement from your table, where it's the data is within the last week, for example, or the last couple of days. That time window is what tells the broker where to go to get the data. Then from there, the queries are then sent out in parallel. All the results come back, and the query broker merges those results into a single packet. There's a lot going on in the data nodes, of course, when the query happens, and we can spend probably an entire talk on how that actually works. There's a lot to read on that, and happy to point you in the right direction if you're curious about how that works. Again, very focused parallelism. The query brokers themselves are really built around this idea of parallelizing as much as you can, and kind of fanning out all the work. And the other processes that are part of the services that are part of Druid are built with the idea of trying to balance things so that the segments themselves are balanced across the nodes, and hopefully get a really nice fanning out of parallel as well. Putting it all together, this is one of my older pictures, so it doesn't really fit the previous look and feel, but it's the same sort of view, just kind of putting everything together, data flowing in, typically into Kafka or some other streaming engine, very frequently Kafka now, but you can imagine Kinesis is another really common ingestion engine, as well as Azure and so on. Those events are coming in, land in a topic, then there's middle managers with the term that you'll see in the documentation again, if you look at my previous doc or previous picture, you'll see those term indexers, same thing. Those are what's responsible for ingesting. Again, that's all parallelized if possible. And then the query brokers and historicals all working together with the deep storage that are sitting there for backup. You'll see Zookeeper there. Zookeeper is part of our coordination services. It's a piece of the architecture as well. Okay, cool. Let me look back, make sure I answered some of the questions. So about Redshift really quickly before I go to the use cases there, let me just, typically where I see Redshift fitting, I'm going to use this slide just because I know this one well. Where I typically see Redshift is in the cold and warm portions. And I see Druid really good at the hot and the warm pieces. Redshift has its spot, and we often, there's times where we've replaced Redshift, but more often than not, Druid is used for the hot use cases. And it often comes up where either Redshift is to be able to scale it to meet the SLAs of the response time. Very typically, Redshift costs too much to be able to meet it, or it fails to meet it. I have some specific examples that we can walk through if you're interested. Again, I rarely would recommend replacing a data warehouse, something like Redshift or Snowflake, et cetera, with Druid. Druid fits on the far end, so the hot data, the warm data. It definitely will serve the cold data too, but almost always it's going to be more cost effective to put that data into something like Redshift, and even maybe part of the warm data use cases. Typically, the way I see it engineered or architected is that I'll see the Kafka stream splitting the data and sending it to the hot data off to Druid and everything else off to something like Redshift, or sending them both to Redshift and just the hot data on Druid, and then slowly moving things off of Druid after it hits a year, for example, or 6 months, or whatever you're trying to accomplish. That's not to say, again, that you couldn't do everything in Druid or everything in Redshift. It's just what I typically see when I see Redshift and other examples like that. And then, Richard, I see your question. There's a limit of voluntary for use hot data Druid support. There's no limit for hot data. So yeah, that's a great question. I'm gonna swing back to my, hopefully I'm making you all sick, back here. There's no limit per se. What I typically see if in hot data, I traditionally will see up to about a year to sometimes 3 years in Druid. That's fairly common. I just did a use case where someone was testing out Druid where they put I think it was up to 5 years. Sorry, go ahead. Okay. I've seen them put up to 5 to 10 years in. In that case, most people, what they do for the older data is they'll not load it as active until they actually need it. And in those cases, just turn it on as needed. In an upcoming release, that's going to be a little more automated than it is now. Right now, you can do that with an API, but later it'll be a little more automatic. But for most cases where there's a hot use case, I traditionally see like 1 to 3 years is the normal, because usually you're comparing, and 1 year is the most common because most of the time you're comparing now against a year ago, and rarely do you need to go back further than that. Tiering helps with that, so you can push things from, you can tier things within Druid, so you can have a hot tier and a warm and a cooler tier is another way of doing that. And then as you migrate from one tier to another, you could also do a downscaling again. So you can say, I want all the raw data for the first 6 months, or all the raw data for the first month, or whatever. And then as it progresses to the next tier, you can then downsample it and do, no longer have raw, but have 5-minute or 15-minute intervals after that, and then an hour after 6 months, and so on. So it's there's not a hard and fast rule. You'll see in some of these examples that the clusters are, Druid can support clusters of about 1,000 to I think I've seen up to 5,000 nodes, depending on how you count a node. So certainly varies because there can be multiple cores. But if you think of like a cluster in general, like you can support really large scale clusters But typically people are, for costs, for performance reasons, you're typically putting things in tiers and then moving things that are older off to something else, maybe even at HDFS and so on. For most databases, there are views and functions available. Does Druid support creating views on top of tables? So there isn't a concept of a view. It's a really good question. There's functions, you can create your own extensions. There really isn't a concept of views like a traditional database has. You can create queries and so on, but nothing like a traditional database view. It's a great question. So one of the other things that gets asked often is, can I build a temporary table? I basically select the last, for data science reasons. And in that case, there's no option for that either right now. So really common question, because it's one that, especially from a data analytics perspective, a data analyst perspective and data science in particular, that it comes up a lot. So let me give a couple of use cases, and then Julia, I want to make sure I answered your other questions. I'll come back to the first question to make sure I got a good answer on that one. Let me give you a couple, given the time, let me give you one or two use cases just so you can lead with a couple of real world examples. All the ones I'm going to talk about are all public, so you can go, there's nothing, they're all blogging about their use cases, and all the information I'm going to show you is all based on blog posts. I've linked to the sources so you can go read the use cases on your own if you want to read a little bit more about them. They're all really, some of the ones I like, the ones I'm going to focus in are the ones that are really interesting, at least to me. So, but the other ones are all linked. And so if you want to see more details about how they used it, a few of them have done, and I'll try to point them out, a few of them have done meetups like this where they've talked about their use case. So you can actually go watch those. And then I'll give you the link at the end, and it's in the, I'll post these of course too. There's a Druid summit coming up. There was one in April, there's one coming in September. And so a bunch of these folks are speaking there. So you have lots of options to learn about these. The first use case is Twitter. Excuse me, this is this is what I was talking about earlier. It's very similar to the origin story. MoPub is a division of Twitter. Twitter bought them, I think, back in 2013. If you're not familiar with MoPub itself, I'm certain that you're familiar with things that are built on top of them. MoPub provides an SDK basically to help mobile application publishers and developers monetize their free applications, basically, right? So we're all playing games, and we're all looking at applications on our phones. And so MoPub provides a way to help those companies monetize their app through ads, right? And by the way, I don't know if I linked the source on it, but on MoPub's website, you can see there, and I think the top, if I remember, it's the top 7 of the top 10 free applications. They're the ones that are kind of powering the advertisements in them. So they're really popular. You may not have heard them. I hadn't until I started digging into the use case, but it's a really interesting one. This is one of the examples I was talking about for Richard's question about how much data. MoPub keeps 13 months of raw data, and this allows you to do year-over-year comparisons. So basically you can say, like, how did my ad perform today versus last year at this time, and so on. So those kinds of comparisons are super common amongst Druid users, and so you'll see a lot of that in these use cases. They have, just looking at their numbers, 52,000 apps. So again, the top seven of the top 10 are included in that. This is the one I was kind of comparing. If you remember, I said, like, back in the meta markets days, it was 30 billion ad requests a month. Here you're well over 1 trillion ad requests. It's no surprise, as we all know, we're all seeing a lot of ads, and we're all interacting with those. So as the ad servers, it submits events off to Kafka, and so does as you use your mobile phone and look at the applications, all the applications that are monetized that way. Those ads are returning events back to MoPub servers, and eventually ending up in Druid. Daily requests.
Let me interrupt. I know we only got about 7 or 8 minutes left. A couple other questions up here. One was
yeah, I see him. Just give me 1 minute. Yep. Thanks for the time check. Yeah, I'll get you guys out in a couple minutes. Let me talk through this one, and then just looking at the numbers, like again, you can kind of see how things are ballooning, and this is the reason why Druid has really picked up sort of the excitement about Druid and sort of the uses of Druid. 80 plus dimensions, growing from, we looked at earlier, 30 plus, and then 25 metrics that previously was like about 5 to 10 metrics. So this is pretty common. This cluster is a really large scale cluster. You'll see the links at the bottom if you're interested in learning more about this use case. Their cluster is one of the larger Druid clusters that I'm aware of. There's a couple of other ones that are in this scale. Most people are starting off in the 10 to 20 nodes and working their way up as more and more data comes in. Really quickly, Netflix is one of my other favorite ones. Netflix uses a lot of Apache Druid, and you'll see a bunch of blog posts out there, and you'll see a lot of like talks that they do. So if you're really interested in this one use case that I'm talking about here, you can go find them talking about it. Actually, I watched a YouTube video the other day of them speaking about this. The Netflix, we're all watching Netflix obviously a lot now. As you're watching Netflix, they're measuring quality of user experience. So from each of the clients, they're sending events up to a central server. Those are going through Kafka and ending up in Druid. It's 125 billion data points daily. So if you go watch that YouTube clip from them, I think I might have linked it. It's on the top source there. If you watch that, they'll talk about how they were trying to get the play delay time down to as small as they could. And you can imagine the dimensions they're tracking, things like what device are you on, what's your network, where are you physically located, all those kinds of dimensions you expect them to be tracking. It's used by a bunch of different users there. They have product managers who are looking, as well as even the engineers kind of looking at how things are performing in general. For the geo analysis, there's a lot of geo analysis. In fact, there's I don't know if I have one that's in here, and I know we're getting close to time, so I won't. I don't think I have one here. There's a couple of Druid, there's a couple of functions that allow you to do geo analysis really easily. You can say like, give me all of the events that are within, a radius 5 miles or a couple kilometers, whatever, within this data point. You can do all those kinds of things, radius searches. There are charting front ends that will use lat long data that's stored within Druid. Most people store their data in Druid as either lat long or something like a geohash that then is pulled out and used on the front end. For IoT and time series data, we've got a number of customers that are users of Druid that I'm blanking out on now. Like the couple that I'm thinking of are delivery services. So like there's an IoT use case that time series fits very naturally into your example there. That's geolocation. They're actually putting sensors into packages. This is a relatively small company, but they put sensors into packages, and these are like large pallets basically, and then track how things events as they go across the country. They're in trucks and so on. So if you think of like a pallet going across the country, they're basically trying to figure out what's the best time to send a specific package and so on. How well does it get across there? Those things are there. There are a lot of use cases that kind of mix those things, as you're saying. I think that's probably it for use cases. I didn't get a chance to do a demo, but I will. I'll link to a demo that you can look at. And there's all these have. I'll just quickly walk through these just so you can see them. All these have links at the bottom, so feel free. You can barely see it here, but you'll see it on the PDF when I post it. They each have a link to where I found the information or who I talked to, etc. In this case, eBay is an APM, so performance monitoring. They do about 5,000 internal applications. They have a great blog about their use case, and I'm pretty sure I've seen them do a talk somewhere as well. This is a common use case. This is the supply chain example I was telling you about, a really great use case for where Druid fits really well and where it's seen some really great yields on the other side. So kind of looking at how well, from the business side, how well it performs. This one's a example of factory floor, works with sensors on factory floors, looking at fraud analysis as well as kind of consolidating all the sensor data from one location. So this is very IoT and supply chain focused. Nielsen Marketing Cloud, ad tech. Walmart's another big user of Apache Druid. They have a blog that I've linked to at the bottom. They don't talk a bunch about their specific use case, but they do talk about how their large scale usage, about 1 billion events per day. I don't remember exactly how they're using it, but they've got a couple of different teams that are using at Walmart. Game Analytics is another one with a lot of data and a lot of great blog posts out there if you're interested in learning more about them. User behavior analysis, so game engine, kind of what you expect them to be using Druid for, kind of checking in to see how users are actually interacting with the game, and A/B testing and all that kind of stuff. This one, I'll point out here, the 98th percentile, under half a second. This is one of the ones I was referring to earlier on. Pretty common for this kind of use case that you're looking for the vast majority of your responses to come back in half a second. Again, you can kind of play with that number depending on all the tiering options and so on. Airbnb is another user. This is Twitch. I think they posted this use case. And Twitch is one of the ones talking at the upcoming summit. So I don't know if they're talking about this specific use case, but you'll be able to see that. Again, clickstream analysis. Lyft is another big user of Druid. I won't have time for a demo, but I'll show you the resources page. If you're interested in downloading, Imply has a package that you can download. It does include 30-day trial of the Imply pieces. If you don't want to any of the commercial aspects, that's totally fine. You can download this distro from the open source page, druid.apache.org. There's a bunch of resources if you're interested. We have a Slack channel that's pretty popular. There's over 1,000 users in the Slack channel, so you can get lots of help from a bunch of different users of Druid. There's folks from Imply on there too to answer if you have technical questions that you want to ask about, or if you want to raise questions to the community. There's a bunch of community folks there. GitHub, of course, you can see the source code and contribute if you're interested. And you can see all of the places to reach out. If you're using Druid now, add it to LinkedIn. It's great to see that growing in use, and seeing folks out there using it's always great, and help promote the community a little bit more. There's a bunch of meetups like this one if you're interested in hearing more. The meetups, if you join the Druid meetups, you'll see about every month or two now we're doing a virtual Ask Me Anything, and it's not me, it's usually one of the founders or one of the creators of Druid. So you can ask them. If not, it's not one of them, it's one of the other smart folks that can help answer how to architect and so on. So if you sign up, you'll get those, and they're virtual, so you can sort of sign up from any of the local meetups. Finally, last point here, the virtual Druid Summit, the second one, we did one back in April. You can see the recordings from that. Again, DBS and a number of other users of Apache Druid spoke at that. Some different customers or users of Druid are speaking at the one coming up in September. Target's a really heavy user of Apache Druid. So they'll be speaking. Netflix is speaking, Twitch and Traffic Guard. There's a few others as well. It's a half day. The recordings will be made available afterwards too, so you can always check out the recordings after if September 2nd is busy for you. And then we'll be doing some more of these as we go through. All right, I think that's it. I went a little bit over our time here, but if there's any questions, happy to stay on and answer them. And if there's anything I didn't, from the questions I got answered, if there's anything that you guys want to dig deeper on, feel free to ask those as well. And if not, thank you all for coming.
Yeah, I mean, if any of you want to ask a question, you can unmute yourself and have a conversation. We would like to make it as much as possible as the meetup in a hall. So, you would reach up to Mike and ask question, right? So if he were to be in person. So please feel free and ask this question. Thank you, Mike. It was a great presentation, a lot of information. Try to wrap around everything. It's a lot of material. So anyone who
Sorry,
has
hopefully
a
it was too wrong.
specific question, I'm sure, I think looks like you answered some of them.
Yeah, I was just making sure I got through.
Yeah.
I think you covered them all, Mike.
Yeah, and if I didn't, by the way, if feel free to, while I'm chatting, feel free to drop anything else in or unmute. You can reach me at mike.mclaughlin@imply.io. You're welcome to email me there. I'm happy to answer open source questions too. So no worries. If you just want to know, like, hey, is this a good use case or whatever, you're welcome to email me there. Or if you want to get feedback, I'm always happy to hear feedback about this kind of stuff. So feel free to email me.
Anyone? Any questions, you guys?
And when's the storm going to end, Mike? And when's the sun going to come back up?
Right.
Awesome. So if there is no questions, and I don't think we have time for a demo, right?
Sorry,
Yeah,
I do have one question.
Go ahead.
We still have time. So
Yeah.
is that possible to query both historic data and the live ingested data
Oh,
together?
yes. Yeah, I meant to come back to that. Yes. Yeah, and that's a great question because it's one that comes up a lot. And I'm going to just, hold on a second. I'm going to bear with me while I remind myself where the slide is I wanted to share. I'm going to pop back into here. The live data, yes. So to answer your question, yes, you can. Live data is coming in to the indexer, and then that indexer itself is creating those segment files, which I mentioned. Those segment files look the same as the segment files that are sitting on these historical nodes over here. They're basically just creating them. On the indexer itself, typically they're going to stay in memory. So if you think of like a segment being about an hour, once it's done, it's going to move off to these historical nodes as well. But when the query comes in, if you say, show me everything from the last hour, for example, and the query broker itself will look and say, hey, where's the last hour of data? Well, invariably, it's going to be over on the indexer. And so the query broker just makes that request over to the indexer. So if you think of like a really large scale system where you've got a Kafka topic with, let's say, 20 partitions or more, even 100, whatever, that live data is coming in on all of those partitions at one time. And so the indexer is going to be splitting the work across there. So as the data is coming in, and each one of those might have a little bit of that last hour on their node, the query broker will just go to every one of those indexers in parallel and ask it, here's the query I want you to run, give me back the response. If you're looking for the last week, for example, including the last hour, then you're going to go to the indexers, plus you're going to go to the historical nodes, these nodes, and ask the same question. That segment file that gets created, there's just basically a map that tells the query broker where is all the data for this specific time window. And if you think of one segment per hour, then there's 24 per day, so it's spread out across the cluster. And so that broker just spans out all those queries, including for the live data. And runs that query in parallel, then the results come back and get merged and go back to the end user.
Okay, thank you.
Yeah, of course. Did that answer all your question about the live data? Sorry, I forgot to go back to that. Did that answer the question? Okay. Yeah. Anything else? Happy to answer other questions related to where it fits and so on, or if there's no more, that's okay too. So. Okay.
I think that's it.
Well, I appreciate everyone coming out today. It's great to be able to introduce new folks to Apache Druid. If there are any questions, again, feel free to email me. You're more than welcome to email. I'm happy to answer those questions over email. If you try the Druid out and you run into some issue, feel free to email me. It's okay. The communities page is also available to, I'm just moving around all over my slides now. You can also reach out on Slack to the community. I'm on that Slack channel too, so you can ping me there. And then if you want to download, you can grab the latest. If you really get crazy, you want to download the latest, you can grab the latest off of master from GitHub, or you can just go download it from your
Mike, is it possible to just cut and paste those links here
in
the chat, so
of course,
people can
great idea. That's a great idea. That's a great idea.
And probably your email information also, if you can give that.
Fantastic idea. Yes, I'll definitely do that. That's a great. I wasn't even thinking about that. And the that one's already in there. These slides will be posted to Chelsea. You'll help me with that, hopefully, and we'll post a recording too. So not that I'm that interesting to listen to, but if anyone wants to send a link off to anyone else, feel free.
It's a great thing, right? So if we have to go back to a particular use case, we can go ahead and do that. So it's always helpful to have the recording. If we are really working on it, I'm sure how many times I've reached out to anyone, trying to find out a user group or someone to answer to my specific question, right? So it's always great to have that information to go back to. So
agree. 100%.
For offering all of that, not everybody does that, and that itself says about how open and transparent the communication is. So I really appreciate you giving all this information and being available for everyone to ask you questions too. I've been in that position. It's not easy to do, and I'm glad you are offering that, so everybody will benefit from that. So we'll post that on, try to usually send out a thank you note with the Meetup group. I don't know, Meetup group is sending out empty messages, so I'm not sure. I think LinkedIn, now I'm going to post it on LinkedIn, and everybody can benefit from there. So we'll do that, appreciate it. Thank you so much. And then we'll, anyone can reach out to me too. If anyone has a topic or want to hear about something, let me know too. Let us know, and we will make that happen. Also, thank you. Have a good one,
everyone.
Good night. Eric and Mike again, and everyone to attend. Thank you.
Thanks, Chelsea. See you guys. Good night.